Okay, I need to remind you of a few things for graphing. Here is a typical problem that we would have to graph, and you suggested I put in an 8, and I agree with you. I'm going to put in an 8. Why is that smart? Because this 8 minus 5 turns into a 3, and if that and that are the same, what's the answer? 1. So 8 comma 1 works. All right? What's another thing I could put in there? Well, what could I make this whole thing into that would work nice? A 1. What if inside the blue there was a 1 right there? Well, then what do I have to make x? 6. If x is 6, then it will turn into 1. And what if you have won the argument? You get 0. Good. So in other words, log base anything, I don't care, IDK of 1 is equal to 0. Get my point? It does not matter what the base is. If you've made this into a 1, your answer is 0. The only exception would be if I made it into a negative base, because what does that mean? Impossible, undefined. And 0 is just as bad because you can't have negatives and can't have zeros. But my point, I wasn't saying that negative 8 is the only thing that would crash it. I'm just saying that you can't crash the problem and then expect that the answer will still be 0. Okay, so just because this is a 1 isn't an automatic 0 unless the base is okay. But the base can be any positive number and you'll get a 0 here. Okay, so 8 comma 1, 6 comma 0, and who's got, wait on that thought, who's got one last point I can put in here? You got a point?
5 and a third.
Okay, now why were you going with 5 and a third? Awesome. 5 and 1/3. So if I do 5 and 1/3 minus 5, do you get how 5 and 1/3 minus the 5 will make it 1/3? And then I'll have log base 3 of 1/3. And that'll be really smart because that is really 3 to the negative 1. Log base 3 of 3 to the negative 1. And then that is negative 1. There, found 3 points. If you couldn't find 3 points, you're in trouble for tomorrow because that's what it's all about. Okay, we'll do another one to practice. No, really, you have to have 3. You only really have to have 2. But I'm telling you, there's going to be hard ones on there where one of the easy points that you're expecting to do isn't going to work. So you better have some options. Let's do another one like that. Instead of log, though, this time let's make it like 5 to the x. All right, first thought on this. Do you know what it looks like? Sketch me 5 to the x. If I don't make any changes, you know what it looks like. Make a quick sketch, just a quick sketch. You should have said this. Is there an asymptote somewhere? Yep. Okay, that's the quick sketch. Yes, sir? No, it's supposed to cross it at 1. Here's why. Would you agree this spot right here is what you're talking about, right? Yeah. Okay, that's actually the y-intercept. And the y-intercept is where x is 0, right? If I put a 0 in right here, 5 to the 0 is 1. That's why it's 1. Okay. Another way to think of it is the starting value is a 1, and you could go 1 times 5 to the x, and now it's starting value of 1. Okay, anyway, there, that's the basic sketch of it. Now, what if I change it this way? 5, make it negative, to the x minus 2. Now, this is going to test your knowledge in something I want to prep you with so you don't screw this all up. Do you remember that there's a difference between that and that? So be careful with this. This one's negative 4 because you square it first and then you apply the negative. This one is negative 2 times negative 2, so it's positive 4. All right? So why does that matter? Because what if you make this into a 1? A lot of people think, oh, 5 to the 1. No, wait. What if you make that into a 0 by putting in a 2? Do you get how 5 to the 0 is normally equal to 1, but then what's the actual answer? Negative 1. Because that negative goes on after you're done with the exponent. All right, so when you're making your list for points for me, make me a list of 3 points that could be on that graph. I'll pause for a second while you try that. So I'm back, and now I'm hoping that you have tried a few points. I'm hoping that you would have thought of that exponent right there. It'd be really smart if you made it into 0, so then put in a 2. Watch, if I put in a 2 here, that becomes 0, but 5 to the 0 gets done first, and that's 1, and then you apply the negative, so it's -1. 2 comma -1. Raise your hand if you had that one right. Okay, good. Next one. If I made this a 3, this is a 3. 3 minus 2 is equal to 1, and -5 to the first power is -5. Get that? I put in a 3. 3 minus 2 makes 1. -5 to the first power is -5. So, all right, on to the next one. If I make x into a 4, I like that because it's going to end up being squared. Because 4 minus 2 makes a squared. -5 squared, be careful, there's no parentheses here. -25, that was an option you could have used. Or the last one I'll pick is if I put in 1 here. If I put in a 1 right up there, I put a 1 right here, then I have 1 minus 2 is -1, and what's -5 to the -1 power? It's a flip of it, so it would be -1/5. Those are 4 options, of which on the test you'd really only have to have 2, but I asked you to make 3 of them. Any questions? Yes?
What about 2 and a 5?
2 and 1/5? Okay, so if I put in 2 and 1/5, I would subtract off the 2, so I'd have 5 to the 1/5 power. I don't think that's what you think it is. 5 to the, or -5 to the 1/5 power is the 5th root of 5. It means what times what times what times what times what makes 5. It's going to be like 1.3 or something weird like that. This does not come out to what you think it does. If you don't trust me on that, take a calculator and try taking -5 to the power of 0.2. 3 to the 1/3 does not equal 1. Yeah, it's okay. You got something backwards in your head. I'll explain it to you later if you'd like. All right, so for right now, I've given you some tips on ideas for, like what to plug in, but let's actually just do one. Here is a graph problem. Try graphing this. Y equals negative log of x minus 4. And I hope you know right now what base that is. I didn't write one, but you should know, therefore, what the base is. Give me 3, actually you don't have to. This is going to be like the test. You only need to have 2 points, and then graph it. You also need an asymptote. Get the full credit for it. I'll pause for a second while you work on that. Okay, so here's some ideas. First thought, put in the base, and then make this equal to the base. So if I made that equal to the base, I could put in a 14 for x, and 14 minus 4 would be 10, and that would work nicely. I'm going to use a 14. Now, would I be able to graph a 14? Probably not. Probably be off my graph, but that's okay. It's a point. So then after I stuck in the 14, I get a 10 here, and log base 10 of 10 is equal to 1, but don't forget the negative in front, -1. Did anybody use that one? All right, good. Now let's try another one. What else could we make that big red circled area right here? A 5, why? Are you sure? Wait a minute, do you mean the whole thing should be 5, or I should put in a 5? Okay, so you're saying make x equal to 5. I agree with you now. So if this is a base 10, then this becomes a 1, and what's 1? What is it when there's a 1 right there? 0, and negative on the 0 still makes it 0. So 5 comma 0 is a good point. Raise your hand if you had that one. Okay, good. And the last one is, let's say we had a, okay, what else could you put there? 4 and 1/10. I like it, because then when you get rid of the 4 and 1/10 minus the 4, you'll be left with just a 1/10 right there. So 4 and 1/10 is smart, because then 10 and the 1/10 can be written as a 10 to the negative 1. And if these two are the same, then that's negative 1. But then there's a negative in front. Negative on the negative 1 makes it positive 1. 4 1/10, comma 1. I don't know if I used that. Did anybody use that? 3 people. Okay, good. Was there any other points that people picked? Yes? Okay, I'll show you what happens if I put in a 4. And that is a really common thing for people to put in, but I don't think it gives you what you expect to give you. If you put a 4 in here, that makes this 0. If you have a 0 there, that's illegal. But it makes the asymptote. If this right here comes out to a 0, if the argument is a 0, instead of the argument being a 1, the argument's a 0, then that's the asymptote line. So you found something important, but you just didn't probably know that. So 4 would give you the asymptote line.
And is that horizontally? Like
Now, I haven't actually graphed it yet. All I have is some points. So let me actually see what this thing looks like. Here we go. Let's say a normal log looks like that. This is not a normal log. This one is, whoa. Let me get rid of all that stuff. Okay. That is a normal log right here. And what will I get if I do this minus 4? I'll go to the right 4. 1, 2, 3, 4. And then that negative in front is going to make it flip. So basically, it should look something like that. And can you tell where the asymptote's going to go on that? Just think about it. There's not many places it could go. You can't cross the asymptote, right? So it can't be like this, or it's just going to cross right through it. It could be like this, though. And specifically, it's at 4, because if you put a 4 there, it'll make the asymptote. All right. Now, how about my points that I said I would make sure that there are in there? So the actual answer is the one that's been flipped, so it's not this blue one. I'll get rid of that. It's the green one. And let's see if 5, 0 would be on it. 5, 0 is right about there. That works. And now, let's get this out of the way here. Make my junk pile over there. Reminds me of the guy who had the junk pile up at the cabin. He collected string because he was the junk guy. He ran the local dump, and so people would bring stuff, and he always, if there was ever any string in the stuff that they brought to the dump, he would take it out. And then he collected the string, and what do you do with a whole bunch of string? You wind it into a ball. So then he started winding this ball bigger and bigger and bigger, and then he had the world's biggest ball of twine. Still there in northern Wisconsin, underneath the big shed. It's huge. It's like taller than me. Huge ball of twine. Okay. So, what is another point on this? 4 1/10, comma 1. Okay, 4 1/10, comma 1 would be something like that. What's another point? Well, 4 is the asymptote. I already had that one, so that's good. That one and that one. And if I just knew kind of where is that, 14, comma, negative 1, 14, comma, negative 1. Oh, it looks like my tail isn't quite sharp enough. Because 14, comma, negative 1 would be like way over there somewhere. And so you'd want it to make a sharper turn, I guess, than what I was making. Okay. If you have 2 points and an asymptote line, and the line's generally the right shape, then that's what you need. I wouldn't have even been able to bust you for that green line being off, because the person had 2 points that were on the graph, and they had an asymptote line. So, all right. I think the best use of your time now is one last thing before I have you work. But if I have 2 to the x, what are smart things to make this? Give me some options. I should make x equal what? 0. I should make x equal what? 1. And x equal what? 2 is a decent option, but there's one more option that's not bad. If I can make x equal negative 1, because then you just have to flip whatever this is. And taking 2 and flipping it makes a half. It's not that hard. So 0, 1, and negative 1 is a pretty good combo. See? All right, how about if it's this way? Log x. What's the smart thing to have for the log? Or, sorry, for the x, the argument there? 10, because it would match the base. Whatever the base is a good thing to put here. What else would be good to put in there? 1 is a good thing to put in because if you 1 the argument, you get 0. Okay, that'll be good if we make x equal 1 or x equal 10. Or what's the last smart option? Yep, 110 or 1 over the base. Okay? All right, I think you're ready. Rest of the time is yours to work on your packet.